Hello friends, and today we'll be discussing a problem on functional analysis. This was asked in GATE. So for previous problems and other problems, you can visit this link. The link is provided in the description of this video. Okay, let's proceed for the problem. Let L2 denotes the set of all sequences which is a square summable. So what that mean? That is L2 contains all the sequences such that if you sum the square of each of xn, then it's less than infinity. Okay. For example, like the sequence 1 by n. Okay. So we know that 1 by n square is less than this. So this implies 1 by n. This sequence is in L2. Now, let the continuous linear operator T from L2 to L2 be defined as x1, x2. So I take a sequence xn. So that has like x1, x2, xk term, and that will go to 0, x1, 0, x3, 0, x5, dot, dot, dot. Okay. And then we need to show that T square is compact, whereas T is not compact. Okay. Okay. Sorry. So we recall that an operator on a Banach space X is compact if and only if for every bounded sequence Xn, the image has a convergent subsequence. Okay, so this is the definition that we say that X is a compact operator. Sorry, so if T from X to Y, we say that this is a compact operator if I take a bounded sequence in X, then the image must be have a convergent subsequence. Okay, so you can using this you can try this problem and let's see how to solve this. Okay. Okay, so what I need to do, I have to show that T is not compact. T is not compact. Okay, so what I will do, I will search for a sequence xn which is bounded, but the image does not have a convergent subsequence. Okay, but image does not have a convergent subsequence. That means like it is enough to show that the image is not Cauchy. Because if image is not Cauchy, then that cannot have a convergent subsequence. Okay, so what I will do, I'll choose a sequence. So I will choose a sequence such that T of that sequence is not Cauchy. Okay? So that will be my target. Okay, so let's see. So let EI be the sequence which ith place is 1. Okay, so this is a sequence in L2. Why? Because if you take the sum, only one term is non-zero, so the sum is 1, which is finite, and hence this is in L2. Okay, fine. So now we take the sequence as xn equals to e2n plus e2n minus 1. So what is x1? So x1 is e1. What is x2? x2 is e3. x3 is e5, x4 is e7, and so on. Okay, and now what? So first of all, we need to see that this is bounded sequence. So clearly, since each of ei is less than equals to 1, is basically equals to 1. So this implies this xn sequence is bounded. Okay, so that is what I have written. Since each of en has norm equals to 1, the sequence is bounded. Now, why the image sequence is not Cauchy? But observe that the image sequence is not Cauchy, so let's see why. What is T of x1? So recall that T of xn was defined as 0, then x1, then 0, then x3, then 0, then x5, like that. Okay. So x1 is like 0, 1, sorry, 1, 0, 1, 0, 0, like that. So it will be 0, 1, 0, like this. Okay. So, and what is tx2? Tx2 is, since x2 is like, x2 is e3, so that has only on the third place, so only x3 will survive, so this is e4. And similarly, txn is equals to e2m. Okay, fine. And now, is it Cauchy? So this is not Cauchy, because if you take any txm minus txn, what is this? This now. So txm is e2m and txn is e2n. And what is this? This is square root 2. Okay. So that is what I have written. And hence this is not Cauchy. And therefore it is the txn does not have a convergence subsequence. And hence T is not compact. Okay. Just recall that what I did. I took a sequence xn equals to e2n minus 1. And then since each of these had a finite norm and therefore this is bounded, and T of xn is uh, is not Cauchy, and hence it does not have a convergence. So generally, whenever we need to find some counter example, this EI sequence will be helpful. Okay, let's see why T square is compact. See, what is T square? If you T square is T of, so on this it's like x1, x3. But now you see there is no non-zero terms on the odd places, and hence T of this will be 0. And hence T square is a 0 operator. And therefore it's a compact operator. Okay? And hence we prove that T is not compact, whereas T square is a compact operator. So thank you for your time and patience. We'll meet again tomorrow. A problem on linear algebra. Goodbye. Take care.